I put them in the hanging file as well, so I do have plenty of copies if you need another copy. All right. So this one's all about writing equations. So we've got Kayleen and Hezekiah are hosting a 5K running race because they're silly billies. It'll cost them $500 to close the roads from the city. And it costs $7 to get custom t-shirts for each of the participants. So we're going to write an equation for the cost of running this 5K, or of hosting the 5K. So, what are our thoughts? What's up? Thank you, sir. And close the door behind you, please. What's your thought on this one? What do we think? So they give us a clue right here. It says it's going to be slope-intercept form. Holy cow, chunky mark Batman. There we go. Slope-intercept form. To me, that means y equals mx plus b. So we're going to have a linear equation here. Where are we going to fill in some numbers? The 500. Okay, I was going to be like, wait a second. There we go. Yeah, the 500 goes into the M. Is the 500 the thing that changes?
Or no, the B.
Yeah, 500 goes into the B because that is a flat rate cost. It doesn't change. I don't care if there's one person running or 3,000 people running. It costs me $500 to get the roads closed. So the 500 is our B. So we know it's going to be plus 500. What is our M?
7.
The 7. $7 for each shirt. So what is the X? What is that counting? Go ahead, Amber. Yeah, X is the number of people. This is the number of people. So it's important to kind of remember that what's going on. Y is going to be our total cost because it's our equation represents the cost. It's important to remember that stuff, to note what it's about so that we can put all the pieces in the right area. Okay? So, B and C are kind of putting those into context. We're going to use the words up on the top. What does the 7 represent? What does our slope represent? Cost of each shirt. And what does the Y represent? Or the y-intercept represent? Y-intercept represent. There we go. The B.
Total cost.
That's what Y is. What's the Y-intercept?
How much it costs
To rent. How much it will cost them?
To rent what?
The roads.
The roads. It's the cost to close the roads. Or rent the roads or whatever, yeah, whatever bizarre wording we chose. The cost to close the roads right there. Part D, like, we're going to look at it separately for a second. So if they charge $30 for each participant to do the 5K, we're going to write an equation first for how much money they're going to make if they charge $30 per person. So what equation is that going to be? Y is equal to?
30x plus 500.
We are looking at this in abstention, like it is not part of the upper part right now. So is the 500 a part of this equation? No. This is just the $30 for each participant. We have that same X. The $500 to close the roads is in our cost equation. It is not a part of how much money we make, unless we get like a sponsor who's gonna donate $500, but that's not a idea. Okay, so what they wanna know is when are they going to break even? Break even means when are they gonna equal each other? So what we're gonna do is we're gonna take our two equations. We're gonna take this guy, and we're gonna take this guy, and we're gonna solve them together. How can I smush those guys together? Go ahead, Amber.
By doing 30x equals 7x plus 500.
Yeah, I've got this guy equals y, and this guy equals y. Let's do some substitution. So we're gonna take our 30x and substitute that in place of y into our 7x plus 500. To figure out where they break even, we want to find out where they equal each other. What do we do to solve this? How do I find out what x is? Go ahead, Amber.
Subtracting 7 from 30.
Yeah, we're going to take our 7x from both sides. That's going to give us 23x equals 500. How do I find out what x is? Divide by 23 and we get that x is 21.7, blah, bitty, blah, bitty. So how many people need to run the race in order for them to make up their costs?
22.
Thank you. Whole people, 22 people. Because if 21 people run it, they won't make their costs back. So they need at least 22 people to run this race. It is honestly pretty easy to do for a 5K. So the last one is saying if they have 45 participants, will they have a loss or a profit? And we want to know by how much. So what we're going to do is we're going to look at our costs. That's our first equation. We're going to look at our income. This is the second one. And then we're going to think about it and analyze it. So the equation for our cost, that's our first one that we wrote, our y equals 7x plus 500. And our income, that's our y equals 30x. So what are we going to do with our 45? Go ahead, Amber.
We plug it into the x.
Mm-hmm. We're going to plug it into x for both of these. So we're going to have 7 times 45 plus 500. And we can put that in the calculator because I don't want to do that in my head because I can't. 7 times 45 plus 500. 815. It's going to pop me up to the top every time. So our y is our total cost, 815. We do the same thing for our income. Y equals our 30 times 45. So we're going to make money from those people. So y equals 30 times 45. $1,350. $1,350. So, if they have 45 participants, are they going to operate at a loss or at a profit? Are they going to make money or lose money? Go ahead, Andrew.
We're making money.
They're going to make money. So they're operating at a profit. How much money are they going to make? Go ahead. Ingrid.
$535.
How'd you find that?
By subtracting 1,350 by 850.
Yes. So we take how much we made and we subtract how much we spent to get our total of, I do trust your math, but I genuinely do not remember what it was. Minus 815, 535. That would, to me, explain how we know. That shows me. I can follow the train of thought. I've got my cost, I've got my income, got my profit of, I found the difference. That shows me. If you want to write things out, fine. If you want to, like, arrows, pointy things, fine. As long as I can follow your train of thought and you don't scribble 20 thoughts out. Sometimes it's hard to follow your trains, especially if you're writing in pen and we continue to change our mind and, like, it's going like this, but there's no arrows. Sometimes it's hard to find your brain. So if you have 20 different thoughts and we scribble a bunch of them out, circle things, draw me arrows, let me in, and help me find your brain. Okay? Because I know it's there. I know it's there. I'm just not always good at translating it. Okay? Questions on question number 2? Should I follow number 2? What else do you guys want to do? 9. Ooh, that's a good one too. Rockets! The Rocketry Club actually meets today to launch a rocket. You could go watch a rocket launch today. Not during school. All right, so we've got the Caroline is launching a rocket in the air. The rocket's height h is, in respect to time, is modeled by this equation. How long is it in the air? So it's got a negative a value, which means it's a frowny face parabola. So what we have is somebody that looks like this. And sometimes I think even just doing this kind of basic-y sketch helps us see what's going on. If I want to know how long the rocket's in the air, what is it we're looking for? Is it this guy? All the way up here? Do I want to know the time that it gets to the highest? No. What are we looking for?
How long it'll be in the air?
How long it'll be in the air? Yep. Which means I want to know when it does what? When it starts and when it lands. What are these 2 points called? Our roots. If we're looking for roots and we have standard form, that's this guy. What are we going to do to it? Break it down. Specific word I'm looking for. Starts with an F. We are going to factor this thing. Yeah. When we are factoring, what's our very, 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 very first step every single time? Not finding A, B, and C. I mean, that does work. You could quadratic formula it. See if it's got a greatest common factor. It's like we don't give you the quadratic formula. So be aware of that. You can do that, but you got to know it. So first things first, let's see if it's got a greatest common factor. Is there anything that all of these have in common? 16. And in fact, since my A is negative, it would be really, really handy if we could make that thing not be negative when we try and factor. So what I'm going to do is I'm going to take out negative 16 as my greatest common factor. When I take negative 16 out, we're going to be left with t squared. Positive 16 divided by negative 16 gives us minus 1. That is 100% supposed to have a t there. And 96 divided by 16, I know that is a thing, but I don't remember what it is. 6. So 96 divided by negative 16 is minus 6. And if that did not have a t there, it was 100% supposed to. So first things first is we look for our GCF. And this is still h of t equals. When we come into factor this guy, for most of us, we do x in box. Or just x since it doesn't have an a value anymore. This is when we take a times c at the top, b at the bottom. And the inside the parentheses a, b, and c. So our a is 1. Our c is minus 6. We have minus 6. Our b is minus 1. I need a pair of numbers that multiplies to make negative 6, adds to make negative 1. Negative 3, positive 2. Which means we can go straight into our factored form here. Our equation, h of t, is negative 16 is out in front. X minus 3 and x plus 2. That gets us factored form. It doesn't quite tell us our roots though. We have to go a step farther. Where are our roots? How do we find those? Set them equal to 0. Mwah, beautifully said. So we want x minus 3 equals 0. Where's our root? At x equals what? Positive 3. And then when we have when x plus 2 equals 0, which means our root is where? X is negative 2. So our roots are at positive 3 and negative 2, which means somewhere in here is our y-axis. Yes,
For the roots, it's not the opposite of.
It is the opposite of these. It's the opposite of the sign that's in here. Since it was x minus 3, we wound up with positive 3. Since this is x plus 2, we wound up with negative 2.
Okay, so when we put in the equation, we don't put like x plus 3 to symbolize it x minus.
Correct. It's when it's from the equation to roots is when it switches signs. All of this is inside the equation, so it's not changing. It's when it's coming from the equation to outside the equation is when it changes signs. So now here's the money question. How long was it in the air? Remember, this is the question that we were asked. How long is it in the air? Where did it start? What time did it start? Can it start at negative 2? Can time start 2 seconds before launch? No. Where does it start? 0. So how long was it in the air? 3 seconds. What this is, they said it weird, but what this is that we have a cliff or top of the school, and we are launching from the top of the school and then seeing when it hits the ground. So they're launching from the top of the Performing Arts Center and seeing when it hits the ground. So it's starting from higher than the ground. Okay, so this one takes 3 seconds to hit the ground. Remember that time cannot be negative. That means it landed 2 seconds before launch, which doesn't work time travel. So be careful of contextual questions like that. What else do you guys want to do? Yeah, Amber.
Number three.
Number 3. Let's look at 3. Oh yeah, scale. We haven't done this since like September. It's been a hot minute. This is when we did the project where we did the room. So what this is I have a picture, or like I have an iPad to a TV. I draw 1 inch on my iPad screen, and it's significantly bigger on the screen, right? Like my little picture is only this big on here. If I draw 1 inch on the drawing, in real life, it means 36 inches. So if I draw my picture of my little doghouse, and it is 3 inches on one side, and 4 1/3 inches on the other, we want to find the dimensions of the real doghouse that we would do with that picture. Because when you draw plans like this, you never draw it 1 inch to 1 inch, like 1 to 1, because then I would be drawing a picture of the exact size of the doghouse, and that's a little extra. So if 1 inch on my picture represents 36 inches, how many inches do 36, sorry, if each one of these 1 inches is 36 inches, right? That's what this means. 1 inch on the drawing means 36 inches in real life. How many total inches does 3 inches represent? Yeah, 108. How did we find that? 3 times 36. So whatever it is, we take and we multiply it. So the 3 inches turns into 108. What does the 4 1/3 inches turn into real life? Yeah. 156 inches. I don't know why I put it up there. So it turns into 108 by 156 inches. Since we have peripheral vision and we notice the next thing talks about square feet, can we switch this into feet? Plus. 108 inches is how many feet? How would we adjust that?
9.
How'd you find that? 108 divided by 12 means this is 9 feet by how many feet on the other side? 13 feet. That is one big old doghouse. My dog's a mini schnauzer. That's a little much. But 9 by 13 feet. That is the size of a very generous bedroom. Okay. For the that's not the laser pointing. For the questions asking dimensions, either one of these are fine. If there's a further question that asks about square feet, it might help to have feet. But like genuinely, both of these are interchangeable for dimensions. Totally fine. Yes, sir.
How were we able to get 9 from 108?
Because we have 12 inches in a foot. So 108 we divide by the 12 inches per foot. And that gives us 9 feet. Absolutely fine. So those are our dimensions. And that is the first half of the problem there. Questions on that part. From there, they're talking about the cost of building it. The special weather-treated composite wood for the patio is $4.75 per square foot. So we want to know how much it's going to cost to fill it, to do the area. So first things first is I need to find the square footage of this house. How do I find the area of the doghouse? How do I find the area of a rectangle? Length times width. Do I know the length? Yeah. What is it? 9. What's our width? 13. Does it matter if I switch those around and put 13 times 9? Nope. Does not matter which one you count as length or width. Pick one and the other one's the other. So what is the area of our doghouse? 117 square feet. If I know the area is 117 square feet and it costs $4.75 per square foot, how can I figure out the cost? Multiply them together. So I take my 117 square feet times the $4.75 per square foot. That gets our units to cancel. And we'll be left with just dollars. That is a multiplication. My pen is being a jerk today. So we're going to take our 117 times 4.75. And we get $555.75. Okay, so these scale ones are a little bit weird to remember. Once you remember them, we'll be fine, but it takes a little bit of time. Okay? What else do we want to do? 5. Sweet. It's another writing equations one, okay? So we've got that Diana works at Kroger for $8 an hour, and Madison does DoorDash. And she's got her 3 most recent pay stubs over there on the right. So we are going to write an equation for Diana, who works $8 an hour. So how can I write her pay as an equation? Yeah. Y equals 8x. $8 per hour. So for Madison, what we're going to do is we're going to look at the table, and we need to find the rate of change. So we're going to figure out how her money changes and how the hours change. And we're going to do both sets that we have so we can make sure our data is good. So, I don't know, just do the first one first. So from 3 to 4 hours, there's a difference of 1 hour. And the amount of money she got paid changed. 39 minus 31.75 by 725. We can look here and see this one changed 2 hours, and this one changed 53.50 minus 39 is 14.50. Is that a consistent rate of change? Yeah, it is. So it's got to be a linear equation. It's always a good idea to check that. We don't on purpose try and trick you, but sometimes things happen. So what is her slope? What is her rate of change? 7.25 an hour, right? So we know that's going to be her slope. But maybe she gets money just for showing up to the shift. So we got to make sure about her y-intercept. So the way we do that is we're going to take, and I'm just going to use this space right here, the piece that we have of our equation, the y equals 7.25x, and we want to see if there's a b value. So what we're going to do is we are going to pick any of our points in here. I'm going to go with this guy because he's not a decimal, because decimals are gross. I have an X, and I have a Y. And we're going to plug these values in. 39 equals 7.25 times 4 plus B. So we want to know if 39 equals 725 times 4. We can do that in the calculator. We get 29. So what's her B value? 10. B equals 10. So she does have a y-intercept here. So she gets $10 for logging in for her shift on DoorDash. And then she gets paid $7.25 an hour. That is not, like, there was no research done on this. I have no idea if that's how they pay. This was done for the equation that we had. So don't be like, I'm signing up for DoorDash. What we're going to do next is we are going to make a graph. What is our X talking about? What's the X value talking about? What do these X's stand for? Hours. So make sure we label stuff. What does the Y equal? Her money. So we're just going to have to number things in a way that makes sense to us. So you could count by ones on our hours. You could count by twos. You could skip count and count by half an hour. I'm just going to count by ones because it's easy. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You should get up to 15. When looking at our dollars, this is a very tall graph. Probably not going to count by ones, though, since we're talking pay. You could count by fives. You could count by tens. You could count by sevens. So that's going to be awkward and weird, trying to figure things out. I'm going to count by fives, but I'm going to skip count and do it by 10, 20, 30, 40, 50, 60, 70, 80, 90, and 100. Okay. From there, all we have to do is graph our two lines. So Madison has a y-intercept at 10. She gets $10 just logging into the shift and not showing up. And then she gets $7.25 an hour. So I could go up 725 over 1. Up 725 over 1. It's going to be really awkward to kind of spot that. So sometimes it's easier to multiply things out. Before we should be at about 39. 10 would be 72, 50, 80. 10 is going to be somewhere around here. Get as many points as you can, but it's like super awkward. But her line's going to be kind of like this. And then you're going to use a ruler. I can't on my screen because my iPad's a jerk. And I don't know how to make the lines show up on Annotate. Madison's is significantly easier to see. She starts at 0 because Kroger doesn't give you a bonus for showing up. If you show up and then walk out the door, you get no money. And then she gets $8 an hour. So at 10 hours, she's right at, that's not 10, that's 11, right at 80. So she looks kind of like this. once you make your graph, there's going to be a question asking you to analyze. Who makes more money at 8 hours? And do not overthink it. I mean, at 8 hours. When it says after working 8 hours, it means at 8, who's making more? I don't know why, but that grammar tends to make people overthink it. So what we're going to do is we're going to look at 8 hours. Who's making more money? Blue or purple? Blue. That's Madison. Madison is making more money. Her line is higher. You could plug in the values and find out exactly what she makes at 8 hours. I know Diana is making $64 because 8 times 8 is 64. Madison's is more annoying. 725 times 8. I can't do in my head. Okay. So work through these. Be careful with labeling things. Make sure we read the instructions and answer the questions that are asked. Part C just has us doing the graph. It specifically tells us to make sure we label the scales and axes. It's also super important when you're making a graph to count by something. I don't care what it is. Count by something. We count it by ones down here. We count it by fives up here. Please do not just take the data in the table and use 346, 346. That's not your data. Okay? Count by something. There are 4 minutes left in the period. We can absolutely work through more of these tomorrow, Wednesday, Thursday, however many we want to do. If we want to wind up doing the whole packet, I'm cool with that. If we want to have a couple of those days where we work independently, that's totally fine. The multiple choice section of the final is Friday. This Friday. Okay? That way we can use Monday to review anything else we want to go through. And then your final in here is on Tuesday, first thing. So it's a week from today. A week from right now, you'll be done with this class. All right? So it's coming, and it's coming quickly. So you have 3 minutes left in the period. You can finish up your thoughts on something. Or just kind of pack up your stuff and have a 3-minute break.